Hello to everybody. Now I'm going to explain problems on P series. So here I'm going to test the nature of summation n square plus n plus 1 by n raised to 5 by 2 plus n raised to 3 by 2 plus 1. The nth term of this series is n is equal to n square plus n plus 1 divided by n raised to 5 by 2 plus n raised to 3 by 2 plus 1. And the bn, highest degree term in numerator is n square, at denominator is n raised to 5 by 2. So we get that is equal to 1 by n raised to half. Now summation bn is equal to summation 1 by n raised to half. The power of n is half, that is less than 1. So which is divergent. Then an by bn is equal to n square plus n plus 1 divided by n raised to 5 by 2 plus n raised to 3 by 2 plus 1 divided by 1 by n raised to half. So then apply the limit on both sides. So after simplification we have this term, and after applying the limit we get 1 that is not is equal to 0. By third comparison test, summation an and summation bn are converge or diverge together. Then by second comparison test, summation an is also convergent. The second problem is summation square root of n cube plus 1 minus square root of n cube, and solution for this problem is an is equal to square root of n cube plus 1 minus square root of n cube, and an is equal to, so rationalize this one, so we get at numerator we have a minus the numerator in the form a minus b into a plus b, so that is equal to a square minus b square. We have to use that formula, and after simplification we get 1 by square root of n cube plus 1 plus square root of n cube. Here bn is equal to 1 by n raised to 3 by 2. So 3 by 2 is greater than 1, therefore series is convergent. Now an by bn is equal to 1 by square root of n cube plus 1 plus root of n cube by 1 divided by n raised to 3 by 2. So here n raised to 3 by 2 goes to numerator, so we get this term, and apply the limit on both sides as n tends to infinity. So after simplification we have half, that is not is equal to 0. By third comparison test, summation an and summation bn are converge or diverge together. By first comparison test, summation an is also convergent. Next problem. Test the nature of summation square root of n square plus 1 minus square root of n square minus 1. Nth term is already given, and take rationalization. So after simplification we get 2 by square root of n square plus 1 plus square root of n square minus 1. Next bn, here bn is equal to 1 by n, and the summation bn is equal to summation 1 by n by p series, which is divergent. Then consider an by bn is equal to 2 by square root of n square plus 1 plus square root of n square minus 1 divided by 1 by n. So applying the limit on both sides. So limit of 2n by square root of n square into 1 plus 1 by n square plus square root of n square into 1 minus 1 by n square. So after applying the limit, so we get the values 1, that is not equal to 0. By third comparison test, summation an and summation bn are converge or diverge together. Then by second comparison test, summation an is also divergent. So next problem, test the nature of summation n square root of n plus 1 minus square root of n minus 1 divided by n. So here nth term is an is equal to square root of n plus 1 minus square root of n minus 1 by root n. So rationalize this one. So we get an is equal to 2 by n into root of n plus 1 plus root of n minus 1. So then bn is equal to 1 by n raised to 3 by 2. So by p series we have summation bn is equal to summation 1 by n raised to 3 by 2. 3 by 2 is greater than, that's why series is convergent. Then an by bn is 2 by square root of n into square root of n plus n square n plus 1 plus root of n minus 1 divided by 1 by n raised to 3 by 2. So after simplification we have an by bn is equal to, so 2 into n raised to 3 by 2 by n into square root of n into 1 plus 1 by n plus square root of n into 1 minus 1 by n. Next, apply the limit on both sides. So we get 1, that is not equal to 0. By third comparison test, summation an and summation bn converge or diverge together. So by first comparison test, summation an is also convergent. And next problem is test the nature of the series 2 raised to p by 1 raised to q plus 3 raised to p by 2 raised to q plus 4 raised to p by 3 raised to q plus dot 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 solution. So here nth term is 2, 3, 4. The nth term is n plus 1. So all the power is there. P is the power. So we have to take power p. Denominator 1, 2, 3. Nth term is n. So power is q. So next bn is equal to n raised to p by n raised to q. So here take n raised to p to denominator. So we get n raised to p minus q. And the summation bn is equal to summation 1 by n raised to p minus q. So here we have two cases. The first case is n power p minus q greater than, if greater than 1, that means summation bn is convergent. Next, second case, if p minus q less than or equal to 1, that implies summation bn is divergent by p series. Next, limit of an by bn as n tends to infinity is equal to limit of n plus 1 raised to p by n raised to q divided by 1 by n raised to p minus q. So after simplification we have limit of an by bn is equal to limit of n raised to p into 1 plus 1 by n into p divided by n raised to p. So that implies limit of an by bn as n tends to infinity is equal to 1, that is not is equal to 0. By third comparison test, summation an and summation bn are converge or diverge together. Therefore, summation bn is convergent if p minus q greater than 1. Then by first comparison test, summation an is also convergent, or summation bn is convergent if p minus q less than or is equal to 1. By second comparison test, summation an is also divergent. So here summation bn is divergent if p minus q less than or is equal to 1. Then by second comparison test, summation an is also divergent. So in this session we discussed on problems of P series. So here these are the reference books to discuss this session. So thank you one and all.